So in these right here, we're going to decide like which one has the highest boiling point. Either HBr, krypton, or chlorine. Their molar masses are similar, so then we'll go by intermolecular forces. So in this case right here, I'm going to have dipole-dipole. And this will be LDF, LDF. Dipole-dipole is stronger. This is going to have the highest boiling point, the HBr. So this one right here, that's kind of the highest boiling point. So if the molar masses are similar, go by the strongest type of intermolecular force. Highest freezing point works basically the same way. If the molar masses are similar, the strongest type of intermolecular force will have the highest freezing point. So if I compare water, potassium chloride, or hydrogen fluoride, so this one has hydrogen bonded. This is ionic, and then this one has hydrogen bonding too. Ionic is stronger. It's the only one that's stronger than hydrogen bonding. So potassium chloride is going to have the highest freezing point. This is why all these ionic compounds, like sodium chloride, they're all solids at room temperature and pressure. Lowest vapor pressure, again, the strongest intermolecular force, lowest vapor pressure. Because then you have to break these intermolecular forces to vaporize something. These are all LDF. They're all nonpolar. Then you go by molar mass. Iodine has the highest molar mass. So it's going to have the strongest LDF. So in this case right here now, it has the strongest LDF. Chlorine is the smallest, the weakest LDF. And so in this case right here, iodine is going to have the lowest vapor pressure. So the strongest intermolecular force, so in this case, they're all LDF, so then you go by the size. Iodine is the biggest. That's going to have the strongest LDF and then the lowest vapor pressure. So again, let's just kind of finish this up, making these comparisons. First one is lowest freezing point. So the weakest intermolecular force will have the lowest freezing point. This is going to be LDF, and so will this. And this will be dipole. Couple of things about it. Then you go about the size. This is smaller, lower molar mass. So this will have the lower freezing point. So this has a lower molar mass than carbon dioxide. Carbon dioxide is around 44. This is about 28. So nitrogen will have a slightly lower freezing point. Lowest boiling point, again, weaker the intermolecular force, the lower the boiling point and freezing point is going to be. So this is methane. This is actually ethane and propane. They're all carbon hydrants. They're all LDF. But this one will have the lowest because it's the smallest one, the one with the lowest molar mass. Highest boiling point, so again, strongest intermolecular force, or you can say the much higher molar mass with that. All three of these, they're relatively similar in terms of molar mass, even though hydrogen bromide is it is bigger. What happens is HF has hydrogen bonded. So in this case, that's going to trump the bigger size of hydrogen bromide and hydrogen chloride. So this is going to have the highest boiling point. So a lot of times it's tough because even though hydrogen bromide has a much higher molar mass than hydrogen fluoride, the difference is that hydrogen bonding is going to oversee it in that case. So sometimes it's easy to make comparisons like that. Sometimes it's a bit difficult to make those decisions.